issues. I mean, after other things contributed, but like I was having like serious lower back issues. And just switched to sanding, and like 70-80% of them were gone.
Nice.
Interesting. Yeah, I think we're live. How do I see the participants?
We have about 10. There are a couple of meetups today, competing meetups. So it's going to be like a mix, I guess. Let's see.
Okay. We'll just wait for a couple of minutes for people to join. So the session is also broadcast on YouTube, so there will be some people from there. Jyotsna will pass on the questions if there are any, so we'll take them as well. Just wait for 2 minutes for people to join. Yeah, let's get started. I think people would join, I guess. Welcome to the Scaling Databases, the 5th episode of Scaling from First Principles series. For this session, we have Nivedita, Srihari, and Swanand with us to share their experience of working with databases at scale. Nivedita is a partner at Nielsen. She has worked at Staples, Gojek, and other clients at scale, designing database-driven software systems. Srihari is also a partner at Nielsen. He has worked at setting up databases at scale, dealing with high-throughput low-latency systems and failover strategies, etc. And Swanand is a senior engineering leader with deep expertise on Postgres. He conducts popular SQL masterclasses with Hasgeek. I think we have a really great expertise on working databases at scale here. Would like to kind of go through the journey and understand how to approach working with databases at scale. Welcome, everyone. So I would like to start the session by actually asking all of you to kind of tell us a little more about yourself and your work with in the context of databases, etc. We can start with Nivedita.
Oh, okay. So yeah, hi. Thanks, Anand, for having me on this session. I have worked with various systems, various database-based systems over the last 8 years. I have the kinds of databases I've worked with have mostly been Postgres and Postgres-related OLTP OLAP databases, and somewhat MySQL, a little bit Datomic, and most recently, yeah, actually, and a little bit of a timescale DBs, like working with monitoring systems and all. So those are the kinds of databases I've worked with. For example, at one of our clients at Staples, I worked with a system, a highly distributed system, which had Postgres as a persistence layer and had a scale of about 300, 400 requests per second, and similar QPS and higher QPS, and had a latency of sub 10 milliseconds, 99.9% latency 10 milliseconds. And I was responsible for, I along with the team was responsible for not just writing the application, but also managing the database, managing the failover of the database, writing code for handling failover of the database. We had a SLA of 5 seconds for the failover. So, and at that point of time, some of these libraries didn't exist and frameworks didn't exist. So it was all handwritten. Yeah, so that's kind of experience I bring. Srihari, do you want to go next?
Thanks, Nivedita.
Yeah, I can go next. Hey everyone. Am I audible?
Yes. Nice.
It's nice to be here, Anand. Thanks for having me over. My experience is similar to Nid. I would classify as an application developer who builds expertise on things all around. Where necessary, databases does happen to be a particular interest of mine. I've worked recently on very highly concurrent systems where correctness has been very important. Like 15K requests per minute type thing, with a very tiny database, but it has like everything had to be perfectly correct, and transactions were super important. Like previous experiences include similar to where Nid came from, right? Like reporting systems on OLAP databases, on time series databases. I've also worked on temporal databases a little bit, like dynamic data script. And the other generic bunch, Redis, BigQuery, etc. And high availability and DBA, I guess, kind of work, and application maintenance and prod support kind of work around the databases has really enriched a fair amount of my experience here.
Thanks, Srihari. Swanand, you want to go next?
Sure. Yeah. Hey, thanks, Anand, and thanks, Nid and Srihari for the intros. So yeah, I come from a pretty heavy OLTP transaction processing background. I have worked in OLAP and analytics processing as well, but I come from a traditional SQL kind of background. I've been evangelizing Postgres for like 7-8 years now. I've worked with DBs for 15 years. And quite recently, we are building, right now, in fact, we're in the process of building a system that's very elastic system that does not process like more than a couple of hundreds requests per second during the day. But then there are 2 times of the day where it goes as high as 15,000 requests per second. And we're in the middle of designing that kind of system, and Postgres features quite strongly in that. And with specific aspect about scaling, I actually love teaching Postgres as well. Like Anand mentioned, I've had hundreds of students. I've taught SQL, schema design, in indexes, and performance measurement, performance improvement, etc. So it's a topic that is pretty close to my heart. And with specific requests or specific topic about scaling, I think there's like I love to bust the myths around how relational databases do not scale. It's a constant topic of discussion amongst the geek circle, right? Like why don't we scale them as much as we can? And so I'm happy to chat and maybe share a couple of opinions, rant, maybe also dunk on a few other databases.
Yeah, I'm looking forward to have more of rants in the coming minutes. Thanks, Swanand. So I want to kind of start with really a simple question, right? I mean, so a lot for many of us, how do you kind of pick a database for a project? When starting a new project, how do you pick a database? Okay, so you look at Hacker News, and there's a new database coming up every month, right? Or maybe every week, right? I mean, so there's something is web scale and something is scales really well, or low latency is really low. I mean, there's something that you're paying for the kind of things they're talking about. So how do you kind of make a decision what kind of database to pick for your project? So there's so many options, and most of the time it's very confusing. So how do you kind of approach it? So I want to kind of ask.
I have one line answer, then I can yield give the mic. Unless you can demonstrably prove that Postgres is not going to be sufficient, you cannot use anything else. Like just use Postgres. And like if you can prove to me that it's not going to be sufficient at the read-write ratios that you want to achieve, at the latencies, at the throughputs, at the data size, like any of those angles, if we can prove that sure it's not going to be sufficient, then maybe we can think of other choice. Otherwise, it's not even a choice, honestly. And I'm sure like Nate and Srihari are coming on the same thing. I want to hear them as well. Like,
sure, yeah. Yes, Srihari, Nivedita, you want to say something?
So yeah, a rule of thumb is go with Postgres. There is a rule of thumb, but the kind of data, you have to understand the kind of data that you're saving. Like, does your data actually have relations between themselves? Like, are you actually, because relational data, yes, go with Postgres. But if your data itself is not relational, like if your data is like, if you have just say like a streaming, very simple streaming data coming in, which doesn't require the complexity of an RDBMS, then you go with something simpler, something like even a key value store. Like, why not? Why introduce a complexity of a complete RDBMS? And then there are other kinds of things to keep in mind. Like, are you not sure the schema of your data yet? Like, are you storing unstructured data? Then you don't go with Postgres, because you won't be utilizing all the capabilities of Postgres at that point. Like if you're going with unstructured data. So yeah, but I agree with Swanand that like 80 to 90% of the time, what you want to go with is just Postgres.
Yeah. Thanks, Nivedita. I mean, I have some points I want to kind of come back, but I'll want to hear Srihari before I want to jump on that.
Sure. So, given that there's enough voice for Postgres, right? Let me give voice to something else. Although I do agree generally with the idea, I think Postgres is a safe choice, right? As a general purpose database, then you're not sure exactly what you need. The one place where I find Postgres somewhat lacking, right, is in one word I would say availability. Right, there is even a highly available system is not generally available. Right, the way other new SQL databases or distributed databases, which are distributed by design, are available, it isn't. And availability puts a massive dent in people's uptime, especially if they have SLOs to their clients or whatever, right? Like if your service goes down and then people don't get food or whatever, that's a bad experience. And you don't want to be there. So at that point, you'll be like, okay, how do I do HA? Now, if you want to do HA for Postgres, you need people who understand what that is. You need to train people in your team to do that, and then be available to fix issues that happen with it, all of that. So if you have a small team, or you want to go an easier route, not necessarily the simplest route or like something that makes sense long term, but if you want something that works, you might want to pick something else. Right, so it depends on what the team knows. It's like you'll have to pick something practical. Like sometimes you might want to go with Postgres, but keep it managed. Right. Sometimes you might want to, hey, you know what? I just need a Redis. I just want a key value store. I can put everything in my database there. I don't have transactions. Or like in the weird 0.1 case that I need a lock, I can do a Redis lock. That's okay. I can do some distributed transactions around Redis. I can manage it. It's fundamentally what my team knows. It's fine. Scaling writes with Postgres has been slightly difficult at times, right? Like it's single node. So if you don't know exactly how to do it, keep your connections really tiny, keep your transactions super fast, maybe you stored procs and stuff like that. That's hard. So multi-master setups, for example, might be like a distributed database might be a good place, or even a time series database might be a good place if you really want like a lot of data going into your DB really, really quickly. Another place where you might not want to use Postgres is with immutable data, right? Like it's not really built for that. Like Postgres, like updates are a fundamental part of any relational database. And if you really don't have updates in your system, all you have are inserts and deletes, then you might want to consider something else. But general sentiment holds. I think you can do JSON everything in Postgres. You can have like 5 billion rows in a single table on Postgres. You can manage it. It's okay.
So for me, like the reason I choose Postgres is, sure, there are availability and everything. Other pieces are challenging, and you could have writes, no writes, etc. But the data integrity that you get with a reasonably well-designed schema is kind of unmatched, and often the high availability setups, I have relied on system architecture to provide that. Add like a queue in the front, manage it, etc. It's a source of truth, and I look at the DB. If you're treating it as a source of truth, then data integrity and consistency becomes your critical requirement from the DB. And then so in the past, whenever I've needed a very high availability setup at a higher throughput, higher latency or lower latency setups, I've relied on queue managers to ease out the load, write load specifically, because like Srihari said, writes are notoriously hard at a higher scale. So I've used like queue managers in the front to ease out that load, and taken on that HA load on the application side, just so that I can continue to rely on the data integrity of Postgres, and Postgres in particular because of its MVCC model, which kind of shines when you're doing concurrency and high concurrent writes.
Thanks. So I want to kind of pick on what Nivedita said about. So she said she'll pick some other key value store or something for streaming data, and said if it's unstructured, we may not pick something else other than Postgres. I want to kind of think about what could be the options, right? I mean, what would be those kind of options?
I have not worked with unstructured data, to be really honest.
Okay.
But your options would be, you can go with Cassandra, you can go with MongoDB. I mean, sorry, had to say that out loud. You can go with MongoDB with at your own peril. But there are options other than in fact, like what Srihari said, that right, like put it in Redis. Like just you have a key and you have a value as a JSON. That's it. You can put it in Redis. But and even actually with the JSON support and everything, even Postgres can, like there's most people write mostly structured data and some unstructured data put in there as part of their schema, even with Postgres. So even that will do, but it won't shine if all your data is unstructured.
Yeah. So I mean, I kind of asked you because, like you said, like for ease of managing, right? I mean, I feel like running Postgres and dumping JSON there is probably easier to manage than maybe managing, let's say, Cassandra or something. I mean, unless you have that expertise in the team to kind of manage that kind of stuff. Okay. So let me kind of bring me to the next question. Like what Srihari kind of also mentioned. Okay. Now you try to pick what the team kind of has expertise on. That's probably the best option. Okay. For the most cases, Postgres is not too hard to set up, and it's battle tested. So that's probably one that you try to pick. But so one thing that I kind of want to ask here is, when we kind of starting out, right? So there may not be enough capacity in the organization to work with internals of databases, etc. So the tendency is to kind of find managed solutions. So my question is, does it really work? Okay. I mean, how much managed is really managed solution? Okay. Do we really need to build expertise in-house? I mean, so my question is isn't that inevitable? Like if we're really working at any database at scale, you'll end up creating that expertise either the hard way or by plan. So I mean, I want to kind of hear about what you think about it. Okay. I mean, is there something called a managed solution really?
There's RDS, right? See, with scale, you really have to define what scale means in this context. Like if you're talking about RDS, like a DB6 R16 instance, that's like 120 gigabytes of memory and multiple terabytes of disk. It works reliable. There's a automatic failover point in time recovery, etc. These things are pretty hard to build. You take any open source system, and some of these things are pretty hard to build, like you said. And if you know that you're going to run into these bounds, upper bounds, of memory, at that point, you can think of going to something else. But my overall assertion is that these bounds are very high. I have personally worked with lower single-digit terabyte, instances for Postgres single instance at a couple of thousand requests per second, at reasonably favorable read-write ratios, and we've not run into significant issues without any serious DBA chops, in our team. And so I really, when it comes to managed services, like my default choice is RDS because of the maturity that they bring. Like the instance that I just spoke about is a couple of $1,000s a month, and you're really hitting it. Like it's a massive machine. Like it's very hard to challenge the bounds of this machine on an ordinary scale. And so that's what I think. Like when I think about managed service, like the RDS offerings are quite solid, and then you can upgrade to Aurora, which is based on Spanner, which we probably might talk about, which is another level of scalability and availability. You can quickly upgrade. So you, in my opinion, like you never need to really build out database reliability engineering team in-house until either your team size becomes too big and you're running into different kinds of limits, or you really do hit that scale, in which case you have other problems as well to solve. So that's what I'm going on. The golden rule there is that same with code, right? With code rewrites and architecture rewrites, you live with bad code, but you always rewrite bad architecture. So similar thing applies to DBs as well.
Cool. That's an interesting perspective. Okay, but are there any instances? Before I go, I want to see Nivedita and Srihari. Do you want to add anything to that? What Swanand said?
Did you want to go first?
Yes, I mean, ditto RDS. There are certain things that RDS provides that unless, as Swanand said, unless you have a very specific team that's managing all of that, you want to have backup, you want to have point-in-time recovery, you want to have failovers, automatic failovers built in, because in most of the cases, database is your single point of failure. If database is not available, your app doesn't work in most of the cases. Unless you're keeping database as a side source of truth. Most of the transactional cases, if database is not available, your application doesn't work. So yeah, all of these things are okay. With Postgres, it's not extremely hard to do it. There are very good community and libraries around it that allow you to do it. PG backups are built in. Replication is built in. You can set up automatic failovers with Stolon or with what's the other thing, Bocado, I think. So these are not the things. It's not like you can't build them up. You can, and with, I would say, with minimal expertise. I'm not an expert in Postgres. I'm not an expert in I don't work for Second Quadrant, but I was able to build that, a failover setup with a backup setup. And so it's not extremely hard to build that if you really want to, but if you have money to throw at the problem, you just go with RDS.
Yeah, I think there's a pretty balanced view. I'll add some nuances that I have seen from experience. One thing is that your DB will go down. One day it'll go down. For sure, it's happening, right? So plan for that. Do you have a plan? And who will take care of it, and how will they take care of it? Try actually taking your DB down and ensure you can bring it up if it is self-managed. And with managed, it's actually often unclear how much is managed, right? With RDS or Cloud SQL, you see backups are managed. And okay, there's a little bit of more nuance there where RDS actually backs up, AWS does volume backups. It doesn't do logical backups. Right? It's not doing a PG dump every night. It's doing a volume disk file system level backup, whatever it is, proprietary. They don't tell you what's going on there, but they give you a certain amount of guarantee. The whole managed thing also brings the notion of trust, right? How much they really trust AWS. What if they hold on to their SLA? Are you okay with just being paid back if they don't hold on to it? And how much do you trust your data? Are you okay with just putting your data at encryption at rest, and then is that fine, right? And like that level of things. But like leaving those things aside, doing backups yourself and testing them often is very difficult. So that's something that you do get kind of for money trade-off with managed service. High availability, again, it's super important. With AWS, you get those multi-AZ. With others, I don't know what, but I'm pretty sure it's up there. One other thing that you would get for free is good defaults. Like AWS picks up the amount of shared memory or the amount of memory used to use for computations and such based on the system's requirements. This is something that you'd have to code down and write recipes for in your own boxes. You'll get that for free. Their default auto vacuum is much better also, right? Like, so those kinds of things you don't have to think about as much. Like Postgres' default auto vacuum settings are for like some 5-10 years ago, and those aren't changed for whatever reason. So if you don't want to depend on those, if you don't want to go understand them, it's pretty good. Building encryption at rest for your data, if you really want that, that's also something that they provide. Where you wouldn't use it is when, say, you want to squeeze out performance. So, for example, one time what we did was we were using a database as a reporting database and a different one as a transactional database. We went and changed the block size and like kernel cache settings so that we can squeeze out performance. You don't have access to the box, you can't do any of that, right? So that if that is your tipping point, then.
So are you saying that this is a replica of the master node, and you want kind of do different settings for this?
Yeah,
server?
exactly. That's exactly what we did. Actually, we had a reporting DB, which was a replica, but we wanted like massive reads, right? And your transaction database is not defined for that. It's not designed for that. So instead of using a block size which is like 8 or something, we used like 10 times that, so 128 or something like that, and then suddenly we got massive uptake in our speed.
Yeah, I think that
you can read some disk very quickly.
Yeah, that's a great point. Like it's like good libraries or frameworks like Rails, for example, right? They have to cater to the general audience and the 80, 90 or 90, 99% of the use case, P99. And same with managed services, they cater to the P99. And if you're beyond that P99, then you're on your own, even with a managed service. And some of that really does require some forward thinking when setting things up. And this the one example you give, Srihari, I think is a good sort of nudge in that direction. That you really need to know your query patterns and your data shape of your data and your usage patterns, and then somewhere you're going to hit that corner, and then what? Then what? And
so actually, there's some interesting questions from the audience. I won't kind of take it now. I think it's so one is kind of relevant to Swanand, what you just mentioned. So what are kind of DB choices to make when designing cases like one write and then reads? Something like a stock ticker. Can InfluxDB fare well here?
Actually, I've never used InfluxDB. Like I said, I would still use Postgres because there's not a lot with stock. See, for high read and like high read write ratios, like where the number of reads are right, relational databases are practically built for that use case. When your writes start getting heavier, that's when you go to other systems. So if you have like low writes, high reads, then most RDBS are going to serve you well. But for stock tickers and all, like it depends like how fast do you want to date. Like there are multiple design choices. Like Chronicle, for example, has a very interesting Java Chronicle framework has a very interesting write up on how they handle that. But yeah, like
it depends on the kinds of reads you want to do. Like if you're doing aggregations, if you're doing groupings, then Influx actually might work really well. So the kinds of usage I have done for Influx was monitoring systems. Like we basically have monitoring stats going into like basically append only kind of setups. You just sending monitoring stats to InfluxDB, and then on the read side of things, you're doing groups over that. So yeah, if that's the kind of scenario you want to work with, Influx might work well.
So to add to this, right, like one write and reads actually is a different problem from stock tickers. Like it's a larger set of problems. One write and read. So Postgres, for example, is very good at scaling writes. This is very good at scaling reads. Right? Like you have read repeatability. You can put multiple standbys and just keep reading off of them, and that scales really well. Writes are hard to scale because it's single write and it's a single node. But if for stock tickers, on the other hand, it's different, right? It's not and reads necessarily as much as it is like, okay, there's this flurry of information coming in. I just want it to go into the database as soon as possible. So timescale DB built on top of Postgres is actually a very good choice, I would say, for that. And it's specifically designed to scale writes and to get rid of data also. So like Nate was saying, like monitoring systems, what they do is they optimize for retention. So you hold X amount of days of data. So Postgres is vacuuming doesn't, I mean, you need to work hard at it to get it to work that way and needs a certain level of expertise. Time series databases on the other side have designed for this specifically. So they would have the data partition by time, because you know the time is a constant in your thing, right? So they partition off by time and then delete off every night a certain amount of data. All these time series data databases have things like roll-ups and aggregates, those kinds of things, kind of first class, which are available to you in Postgres, but might not be as highly performant as ones that are specifically designed for them.
Yeah, like batching is a great example. If you always need to read data in large batches, then a relational database may not be the best choice for you. You're better off doing something like a Cassandra or something, where you can have wider rows and just keep reading those. Like they're very optimized for those kind of things. StockTaker could be like a good example for that. You always need to read all the values. It may or may not be a time series, but just a large collection. And in that case, Postgres, you have to set it up in a very specific way, which needs a lot of schema design maturity, which again may or may not be present.
Yeah. So I mean, I've not worked with InfluxDB, but I think I can add something for the stock ticker. So we had Kailash Nath from Zero on the second episode of scaling from first principles, and so I think they have a very similar setup. They have to kind of broadcast this stock ticker to all the users. I think they use a setup with Postgres plus Redis, where they have massive Redis cluster sitting in front of Postgres, and that keeps broadcasting to all the users through sockets or something. I think you can. They have a blog about how they do all the stuff. I think that's a good place to check out.
This is a testament to hell yes Postgres.
Yeah.
Very clear answer to like, oh, stock ticker.
Yeah.
Been there, done that. Postgres is at this point.
Yeah. So there's an interesting question from Chris. Scaling databases comes with scaling migrations. Running migration, adding columns, deleting columns, right? Can bring down the database. What are some good strategies for doing migrations for databases with and without sharding? And end goal is to avoid downtime and prevent API server from throwing exceptions. Who want to take it?
Go ahead, Swanand. I have a bad story about this, so I'll go in the end.
Cool. All right. So again, I think we are becoming far more, like we are basically becoming Postgres discussion here. For migrations, the absolute minimum is DDL transactions. Like I honestly, after years of working in DBs, I do not know how to do zero downtime migrations without DDL transactions. Without said, otherwise, like you need a lot of different setup. But yeah, like there are a lot of standard patterns out there for specifically for risky migrations, like adding default values to large columns, etc. Shopify has a really mature library for detecting some of those. But there is no silver bullet. The real answer is that your development process has to be mature enough to handle it. I have not seen any automatic way of managing and just doing what you want without taking some downtime hit. The real answer is that you have to manage it in your dev process. And I also have like a couple of horror stories, like database going down because we added a default value and big int issues, etc. All related to migrations. I've been burned a couple of times. But I want to hear your story, Nate.
Yeah, I think it's about I've learned this also the hard way. It's about setting your developer practices properly, like how to deprecate a column. It's important. Like never drop a column. Like as your first thing, like deprecate that column. Make sure there's no code that's using this, and then maybe in the second as part of second deployment, drop the column. How to so yeah, and int IDs are the most common issues all growing companies face, where when the schema was first designed, no one thought that the ID would actually cross integer. Like that's how they design it. Like, oh yeah, it will never cross integer. And then 3 years later, you still have an int ID in your system which is sequentially increasing, and it's if you've not noticed it on time, you have 2 weeks before it will overflow. Now what you do, and your database is of size of 1 TB. Like you have like a 50 gig table. How will you change this primary key value from integer to big integer? So just you have to, I think the one thing that you have to keep in mind is like think things through when you're designing the schema. You have to think about like how will my schema look like if things will infinitely grow, like if my table has to just infinitely grow. Use UUIDs, use string IDs, use like and like big int. That's like a very obvious answer, but like a big int also has its limitations. So then just use UUIDs as IDs. So yeah, my horror story was a 1 TB. It was not my team; it was an adjacent team, but it was a 1 TB database with 2 weeks left, and ID reaching its overflow limit, and the entire app will come crashing down in 2 weeks. Have to migrate this whole thing.
I actually first thought you were talking about schema migrations, Anand.
Yeah.
But that's a different story. If it's about data migrations, yeah, this gets a lot more interesting, right? So the regular, like the default value and the big int and overflows stories are all covered. So I will.
No, actually,
the question was schema migrations. Yeah.
Yeah.
Question was schema migration. The one thing I would say about schema migrations is, I mean, yeah, try it out. Right? Like, how hard is it? Get your prod DB locally and try it out, or like put it in a mirroring environment in perf. See it working. Ensure that your application doesn't go down. Right? Like, put a health check on it. Keep running the health check, and then perform your migration. See if it works, and then tweak it and work on your process until it works.
I think the key.
Yeah.
I think sorry. I think the key you mentioned is like you have a copy of production database, and you're mirroring same traffic on it, right? I mean, I think that's a key.
Or either way, actually, we can work with it. There's a whole gamut of things that you can do in between. If you don't have a prod database, then it's impossible to get a prod database for you. Like, for example, you have sensitive data there. You're not allowed to have sensitive data. I mean, create something that's somewhat similar. It's harder to do, obviously. You have to create that data. You need something that generates that data and then pipes it into your database and all of that. But if that's possible, do that. If it's possible to get prod data, nothing like it. If it's possible to mirror your prod traffic, that's the best thing, right? It's like actually trying it out like on a prod system. Best. If you can't, if you don't have that, try to simulate that. Try to simulate some of the requests. Like, one of the things that we do is like any transactional service generally has like a message bus with events coming out of it, which usually mirrors the database, you know. So consume that and then pipe that into a request stream into your different service. That it's sort of like a mirroring of prod traffic with you building us like a small thingamajig to do that yourself, rather than rely on actual prod traffic. And if nothing else, you can just like set up Vegeta or something like that to throw at your system to instrument a little bit. Different things with different amount of time to build and have each one of these things. If you are performing data migrations a lot of time in production, it's probably good to set these up. But if you're also performing schema or data migration time things in production a lot, it's probably a good idea to reflect on your schema design in the first place. Other things are like, I would add indexes concurrently, and like very big migrations, I would use ETL systems to like actually create an entirely new database with an entirely new schema design. Move the entire data over slowly. When the other system is over, just switch to the new database. An easier way to do
Agree.
this is use logical replication or PG logical or one of these things that give you a SQL stream that you can put it into a different schema potentially.
But
Those deployments are like getting very popular, especially with zero runtime migrations. You want to bring up that replica, switch over, all those. I have two principles to share, Anand, if you
sure,
allow me, on the same topic of schema migration. One, again, slightly abstract tip, but they serve me quite well. One is like bounded queue principle, right? Or the design pattern, like be extremely aware of every single bound in your schema migration, right? It could be value limits, it could be connection limits, pool size, read write ratios, etc. All kinds of bounds. Those, like the probability of a bounded queue or a value going out of the bound that you thought it was is very high specifically during schema migrations. And so again, goes back to developer practices. And the second thing is forward and backward compatibility, especially in the container world. It's quite possible that your code will be ahead of DB or your DB will be ahead of the code, and you have to account for both the possibilities. So all the code that you write, the application layer must be forward compatible and backward compatible, which means like renaming columns and those kind of things are like completely out of question because you never want to get into that kind of soup. And so these two principles have served me like well over and over again whenever I'm doing like live migrations and on high availability systems.
Doing a select star, for example.
Right, or like delete from without qualifiers. I'm just kidding.
Cool. So there are a couple of other questions. I think they're very specific to Postgres. So is PG good for text searches?
Actually, is there anything non-Postgres we should? I was thinking like, maybe we can hold on Postgres for a little bit because all of us has a clear fine voice. Fine girls.
Don't worry. MySQL is also coming up. So
okay. Sorry. Go on. What was the question?
No, yeah. I mean, is PG good for text searches?
Yeah. I mean, it is. And I mean, when you say good, right? Again, good is a very dicey. See, Postgres has soundex, trigram, TS vectors support built in. And if your search quality is good enough on those things, there are 4 or 5 different tools built into Postgres with indexing and all support. And if the quality of text search that you're looking for matches those tools, like specifically these there's TS vector, trigrams, and soundex, and a couple of others. If your search quality is good enough with these 3, go for Postgres, because the operational nightmare you'll reduce with something like Elasticsearch or something is like a couple of orders of magnitude. Postgres, and I think by now MariaDB and MySQL to have amazing support for languages as well. If you're working with multiple different languages, they do these things really, really well because they're fundamentally built into these systems. So like my fundamental rule is like these are the 3 things that I try, and if that fits in, then I go with Postgres or the database that I'm working with, and the only real option like MariaDB. But otherwise, then you're back to like Elasticsearch, where you can write like custom wrappers and custom indexers and all those things. So that's my sort of take on text search.
Srihari, you have anything to add?
It's very good, I would say. Is PG good for text searches? Yeah, there's a lot of indexes that are very specific text searches as well. There's an entire manual on how to do full text searches in Postgres, and all of them are performant and like they're being worked on constantly. That said, like I think mostly have Swanand's opinion on this, which is at a particular scale, if this thing doesn't work for you, Elasticsearch or Solar or something like that, where it's the entire database is custom built for search, is going to perform better. and it's a difference, right? Like that where I think it's like Flash optimized or whatever, right? Like Postgres it works very well on disk, but if you are confident you'll have everything in memory all the time, there are a bunch of different kinds of optimizations that the likes of Lucene, Solar, Elasticsearch, and these things will provide you that you won't get here.
I think there's one more thing I want to add on this specific topic. The decision to go with Postgres or Elasticsearch truly comes down to two things. One is search quality, which I said, like, figure out the tools that Postgres offers. But the second is, like, again, read-write ratios and how much freshness do you want in your search. There's going to be always some lag. You run into sync issues, etc. And then do you have the operations maturity to handle a different system? And those are like the general standard decision framework or decision points that I use. And they, like I said, most P99 cases will be served with these two things. And if you are in that P99 plus, then I'm sure like you have a lot of other options.
Yeah. Do you have anything to add? Cool. So there's one question on MySQL. So the question is, like, from a SQL programmer perspective, is there any difference between MySQL and MariaDB?
Yes, no. I mean, I don't know a lot about it, but I would pick Maria over MySQL any day. I think there are fundamental things about design that have been changed in Maria. I mean, that's my understanding, at least, right? Like with MySQL, one of the fundamental design flaws was that the integrity engine, or what do you call that? The persistence engine, NODB, is not built in, and it's pluggable, etc. And with Maria, it was fixed firsthand. And a lot of the tenets of Maria are very similar to Postgres by design. Of course, like my knowledge on this is very scarce. Sparse, one of those things.
Yeah, I'm actually in the MariaDB camp when it comes to MySQL versus MariaDB. It has matured and evolved over time quite a bit. They even added DDL transactions, which was my biggest pain. So yeah, I mean, there's no difference. I mean, there's no choice there. MariaDB seems like a clear winner. It's also support and managed. So if that is the worry, then again, you have commercial support available if you truly want to, go with MariaDB.
So when you get RDS, do you get MySQL or MariaDB?
It's MySQL right now. And again, like, because I'm such a Postgres person, I may have to go look at the documentation.
Okay, cool. So the other one is actually pretty interesting. As Abhinav is asking, can you talk about how to design tables, schemas for high scale? I think that's coming to one of the things that an important topic. Like, how do you kind of approach designing schemas, and so what are your first principle approach, and how do you think that you should do and what you should avoid when you're designing schemas, right? I mean, what to start?
Nitya, do you want to take this?
Yeah, I can give it a start potentially.
Sure.
So you can take, I mean, on the spectrum of like heavily normalized to heavily denormalized, according to your application, you'll have to like start somewhere, like see where you fit in. If you have low traffic and you want to optimize for domain modeling, then maybe pick a normalized schema to begin with, and then as and when you need performance, slowly move towards denormalized ones. If you know that it's going to be a performance system from the beginning, maybe start moving towards something denormalized right from the beginning. It really depends on the domain and application. I don't think there's a one size fits all, like a straight approach for schema design, right? It has to be based on the problem statement. Even within that, like for the database, for the table, for the column, there would be design. Whether I would pick like multiple columns for one thing, or like one JSON field with all the 3 columns, also depends on domain. I'm finding it hard to answer.
Schema
Yeah,
design is a data modeling and data integrity issue. So sorry, Nid, go on.
yeah,
I'll
I
continue.
was sort of going with there as well. Like schema design mostly completely depends on your data model, and so there are things that you can do, right? Like say you don't always have to go for joins. Sometimes doing n+1 and n queries over joins is better. Like you do, even if you have a normalized data set. When you wanna, you can avoid joins if you want to avoid joins. But to be really honest, I think I have done 2 table 3 table joins at scale on Postgres, and you can it's pretty optimized for that. So it's not really like you won't get that much of a performance hit even if you're doing joins at scale on Postgres, at least
Actually,
in
there
my
is, right? Like there
experience.
is. So I've found joins to be costly when done at very large um, data sets with very large data sets. With small ones, of course, it's fine, right? It's if it's the equivalent of doing like 2 index lookups and then like joining, that's pretty simple. And if that's what you're doing in your transactional high throughput system, that's completely fine. But if you're in the same system, if you're trying to like do like massive joins to get the data out, that might not be as
Right, yeah,
performant.
depends on the kind of joins you're doing. Like that's why I said, like if it's just say 2 table with indexed fields, then it's not that much of a difference than doing two queries over it. Like you don't get that much of a difference there.
Actually, even like two or 10 tables doesn't matter so much in my opinion, as much as how much data you want to read. If you are joining across multiple tables and want to read like thousands, hundreds of thousands of records, that is when the joins are going to probably kill you, because then the disk reads and all are not optimized. If you're looking for isolated records, smaller number of records, no amount of join like is going to stop you. Postgres will perform optimally as long as you have the adequate indexes set up. But if you're reading large paginated data, or like I said, batch reads, then there are clear design patterns where you might not want to use joins. You might want to do like table scans and return the data fast in memory. And again, but going back to specific about high scale and schema design, we really need to stop thinking about schema design as a scaling tool. Indexes are not a design tool. Indexes are a performance tool. You can add whatever index you want. You can create views. There are multiple tools available. You can create materialized views, regular views, foreign data wrappers. There are so many native built-in tools available to bring performance to your correct schema. Schema design must always be about correctness and integrity of data. You have to get that right first. Go for first principles, and then you can build a lot on top. Like I said, you can build application layer things, whatever, Kafka, Elasticsearch, other things, Redis, etc., on top of your Postgres or your source of truth, which can get you all kind of performance or whatever it is you want. Like in worst case, you can have a beefy application machine which just reads all the data and keeps it in memory, etc. And so you can do these kind of patterns if you're truly worried about performance. But schema design is not something you want to truly optimize your performance about. For series,
There is something to say about, there is something to say about transactional schema versus say reporting schema, right? Like you want to move
Agreed.
from your the schema needs that your transactional DB needs will not probably be the same that your reporting DB needs. So you want to have some sort of ETL in place, like do transformation, do move from regular schema to like a star schema or a snowflake schema, and you transform your data into that kind of schema and save it in another DB, and then your reporting can be done on top of that. So in that way, I guess schema can be related to sort of scale in some way. But yes, in most cases, you want to think of schema as from a data modeling perspective.
To add to that, I would actually prefer a slightly different schema for reporting if I have a lot of reporting needs. And for that, I would prefer something like a view, for example. Like if the problem is writing a lot of SQL, right, a view would solve it. If the problem is creating a reporting schema, but not creating a reporting table within ETL, a materialized view goes a long way in solving that midway, right? So it's not just table schema, I would say. So if you consider views and materialized views also a schema, they are available on your regular normalized thing that
Is it just
works
me
well
or
for
is
your domain of like. Can you hear me all right?
It was breaking a bit in the middle.
Is it
you went off for you went off for like a 20-second time period. You're off.
Yeah, I think it may be fine now.
The materialized views and views. Is it fine now?
No, I think it broke again. Would you try turning off your video, see if that helps for a while?
Yeah, sure. Is this helping?
Yeah, quite. I think it's clear now. I think we lost you again.
Maybe we could come back to that later. Yeah.
So Swanand, I have a question for you on the topic that you mentioned just before. Okay, you're talking about when you answering the question about the joins, right? You said and the performance of that really depends on how much data you're reading. I mean, I want to kind of I'm not sure if my understanding is correct on that. So what I think is, like, if you have a lot of tables you're joining, the time it takes actually is to kind of compute what data to give. Even if you're actually reading first 10 rows, computing the first 10 rows would actually be take really long time, right?
I mean, that depends. Like, are you doing index only lookups? Are you doing like indexed lookups versus index only lookups, etc. If all your joins are indexed and all the data that you want to read is on the index, like for example, if you have a composite index where first one is say customer ID or order, and the second one is like timestamp, you're looking at some orders or something, like a very stereotypical example, and then you're just looking to sort, and there's like a complex join. And those are the kind of reads that are fairly fast, no matter what joins you have. But like I said, when the problem starts when your data is fragmented in various places on the disk, and now you want to read all of those, because Postgres vacuuming works per table, and it may or may not always work out in your favor if you're doing joins across the different tables.
My point is, like, sorry, go on.
No, that's it. The other time when sometimes joins have been known to perform poorly is when the tables are disproportionately different. A very large table with a very small table, etc. Again, because Postgres and MariaDB, we do a lot of heavy optimizations based on the read patterns. Whatever is read frequently will be fresh, etc. And so if you have disproportionate data, then that can also affect your join performance specifically.
So my point is, like, let's say if you add if you're just doing a plain join, that may work, but if you add a group by or something on top of that, that may actually compute heavy, I believe, right?
True. Yeah, I mean, group by aggregations, obviously, fundamentally they can always be slow because aggregations work on a different level of data. You have to assimilate the data first and then aggregate it. So if you don't have specific indexes or specific, if you don't get lucky, then you're always aggregation is always going to be slow as compared to your standard lookups. And again, like the thing that I keep going back to is that if you're doing all of these things, right, that probably speaks to your primary, secondary, and analytics and reporting schemas, right? You may want to take a different approach to your source of truth versus your analytics store. And those are, again, some schema design maturity, some application layer maturity sort of is needed there.
Cool. So there's a question from Abhishek. In the age of big data, ML, AI, are there any kind of database design patterns that should be focused on?
I didn't get the question. Can you please repeat?
In the age of big data, ML, AI, are there any kind of database design patterns that should be focused on?
I don't know how to
Looking at
answer it without
large-
sounding very cynical.
No, so assuming that you have enough amount of data to do AI and other things over, you're looking at an analytical database, right? So possibly something columnar, something like BigQuery or Redshift or any one of those things is generally what I'd use. Yeah, especially just because you can write extremely large queries over large queries over larger sets of data where you're even potentially joining over multiple databases and things like that. Yeah.
The one thing is like,
if I would use plain old Postgres for analytics where I'm clearly going into like hundreds of TBs of data.
the thing is AI and ML are compute elements and databases are storage elements. There's a lot of impedance mismatch in that thinking that AI and ML like they're sort of compatible. They're also ML systems one of the reasons why Hadoop uses its own file system, like the traditional file system does not serve its purpose. And so I don't think AI and ML and Postgres or data stores can be compared that way or should be thought of in that way, specifically because one is quite heavily a compute problem. Like you can just get a 120 gigabyte RAM and put everything in memory and run pandas or CUDA or something, and then you don't really need any database to do any of your work. Databases are about storing your data and retrieving it truthfully, and then all other layers on top of that. So that's how I think about these two topics specifically.
So I haven't really worked at very large data and ML and AI space, but I worked with a lot of ML stuff. So one thing that I found useful is the complexity is actually keeping the data in the right shape and kind of accessing it when needed. So what I found actually is the pattern that worked for me was make S3 your primary source of truth. So all the data is actually dumped in S3, and from there it goes to the Postgres database for all your queries, etc. And since there's a lot of ML load, you want to kind of repetitively train your data models, etc. You have bulk reads, and you want to do bulk reads. What works is, S3 works a lot better than actually working with database. So I partition the data by day or a week, and then dump it in S3. And whenever the data is modified, I rewrite the entire thing into S3 like that. And that can work really well for me because that's very easy model to kind of think about and explain to a data scientist that I'm working with. Right? If the data is changed, that gets updated in the S3, and then that gets pushed to the database. So that becomes like when the world becomes very simple to kind of think and understand, and that's what kind of worked for me.
Yeah, I was under the impression that the question was about assuming you had an ML system that had to read from a database. What kind of database would that likely be, and what kind of data would that read from? Yeah, it makes sense. Like if you're going to just use, like if you're fine doing in-memory computations, then you don't really need a database. Right?
No, I think there are two parts to ML system, I believe, right? One is when you're training, you want to do bulk reads and can do that probably in memory. But when you're kind of doing inference, you want to hit some database and get some data. So you probably need both of them.
Yeah, sure.
Yeah. So I think there I think many more questions kind of pouring in. I think we're kind of 7:30. We'll wrap up in 10 minutes. So let's kind of quickly see what else we have. I think there's quite interesting questions. So one use case to use database. So this is a question from Vishal Melmati. One of the used database other than RDBS could be like MapReduce, where we need to do computation near the data instead of fetching the huge amount of data from the database to application. What are your thoughts?
Yes. Yes, there are, when you need to do MapReduce, like go with a file system like a Hadoop thing or like a more of a streaming thing that you can do MapReduce over. In that case, an RDBS won't do.
Actually, on that specific topic, the reliable queue management systems are actually quite nice data stores. Kinesis, Kafka, or these are also like quite reliable. They hold your data reliably. You can read large batches, and if you have a very heavy compute element, then like Anand said, S3 is probably the best. Honestly, flat files or Parquet or something. Like you can pick your format, but you want to be very simple. You don't want to take the ACID overload. And in my opinion, even queue managers like work really well.
Yeah, with Kafka Stream especially, you can do a lot of computations on top of the data coming in from Kafka.
So I think there are many questions kind of pouring in. Let me see which ones to pick, given that we have a short time. There's a question from Pratik. In what scenario a NoSQL DB like Mongo, DynamoDB, an obvious choice over just using JSON columns and RDBMS?
Should I take that? Like, Srihari, do you have anything?
Yeah, I can give it a shot. So basically, if you don't have transactions, right? If you're just holding data and you're just looking them up, if you're not writing into it much, you don't have any transactions. There can be that kind of data, right? Like it's just like a catalog lookup, for example, where your data has like different kinds of structures. It's not easy to put into a traditional table. Yeah, if it's just a lookup, I think I wouldn't mind using a key value store. Dynamo would work very well, just as any other potentially a document-based key value store, or just Redis. That's when I wouldn't use Postgres. I don't need, like Swanand was saying earlier, the cost of ACID.
Yeah, so in fact, I have the perfect use case for that in the current DB that we are working with. Data is only written; it's practically never read from the primary store. We are on Mongo Atlas. It works fabulously. The writes are insanely fast. Like 10,000 writes per second. It does, and then we need the analytical data where obviously we ran into Mongo is not great for analytic queries, so we had to. We are building like a streaming where the secondary DB is going to be Postgres where you can add hoc queries. But it just goes back to the whole thing, right? If you have two different distinct set of requirements, just use two distinct stores, and then the source of truth can be close to your domain model. So
I would slightly disagree. I don't think I would use Mongo for writes because consistency. I still need consistency, right? Like if it doesn't store on disk, like despite all the journaling and all that, if it doesn't write to disk every like 1 ms, if I'm writing really fast and like at one point if the power goes off and comes back and my box suddenly swaps and Mongo loses my information, if I'm not okay with it, I won't use it. I would use something that does promise that, which is why I said reads. Right? If it's reads you're optimizing for, you don't need something like a transaction database.
Yeah, and I think those who are looking into Mongo and want to use Mongo, DocumentDB is like a perfect API compatible replacement, which is built on Aurora, which is a distributed SQL engine. So you get all the benefits at only few of the costs. So a pretty good alternative. As you can see, I'm big on AWS. It's because most of my experience does come on AWS. So I'm biased, probably.
So the question on that is basically, so why didn't you use a queuing system? Why did you go with Mongo?
Actually, I did not design this. I'm redesigning it right now, and I'm using Postgres, and we're using like a domain-driven design model there because there is clear separation. Like we're also running into product issues where we're not able to effectively develop or make product changes because some of those design decisions in the past. We are rewriting that. Maybe we're also writing. We're doing a case study with AWS as well. We'll be publishing that pretty soon, maybe in a month or two.
So I think I'll just take one last question, and then I have one closing question for all of you. Okay. So this is so this is a question from Daksh Verma. What's the best database storage system for storing images? File system, RDBMS, GridFS, Minio, S3.
File system, like really like S3, like or MinIO is like a pretty viable choice if you're willing to take the ops. Yeah.
The idea is the same thing, like S3 or MinIO.
Yeah.
Should we talk about why? Are we
Yeah,
just rolling out advice?
Yeah, no, sure.
We can move on to other questions, but yeah, basically you're not operating on it. You're just storing files. So put it in a file storage mechanism or an object storage like S3.
I mean, I would say kind of use S3, but actually use some database for indexing all of them, and you can query stuff if required. So, but make sure the S3 is the primary source of truth. Add all the tags, etc., in the images itself, so that you can reconstruct the image if required from S3 itself. That's what I would recommend.
Yeah, that's my go-to approach. Like put the image in S3 and put a link in the DB.
Yeah. Okay. So I think we're yeah. So there's a question. I think this is not sure if you can take it, but it's an interesting question from Chris again. When you decide to shard the database, and what are the data points you collect before sharding and after sharding to measure the effectiveness? Okay, I think we haven't touched upon actually sharding and partitioning. That's something that I want to bring up, but it's quickly. Can you what kind of talk about that?
Are you talking about node sharding, like distributed, or are you talking about data sharding?
I think it's talk about data sharding. Grace, can you confirm? Yeah, I think let's assume it's data sharding.
Right. Let's assume data sharding.
Yeah.
Right. Yeah. So my approach with any transactional database has been that if like I actually use partitioning or sharding as a way of archival in my transactional DB. Like your transactional DB, you don't want it to grow beyond a certain point, like after a certain point, and at any given point of time, most of the time you're only working with the most recent or the most part of your, at least part of your data, the most recent part of your data, like say bookings, orders, or whatever, any kind of things, like you're working with the most recent part of your data. So time-based sharding is the most common kind of sharding that you can do. And Postgres comes with the latest versions of Postgres. It comes with built-in built-in partitioning support. Before that, what we used to do was we used to use something called a PG partman to do trigger-based partitioning. So now Postgres comes built in with it, and what partitioning helps you with is very easy archival. Like you keep 1 week worth of data, or you keep X period, like 1 month, 1 year, how much ever you want, and the rest you can archive. And with logical replication, your archival becomes, for the transactional DB, your archival becomes even simpler. Like you only delete data from the main master database, and you don't replicate that in the replicas. So your replicas have much like the whole set of data that you need. So that has been like my approach to partitioning has been always like, the moment you've hit production, the moment you know you're going to hit site scale, think of partitioning, build your schema, like partition, make it built in from the beginning.
Yeah, Swanand, do you have anything to add?
Yeah, I mean, like I generally tend to prefer quite a bit on logical sharding, which I can control from the application, because I come from the heavy schema side. But lately, I've been sort of leaning towards the Vitesse style automatic sharding, where you use uniformly distributed numbers or uniformly distributed data types to actually shard and then do it transparently. It works great. Slack uses it to great effect. It has some shortcomings, but truly, like, I mean, from a first principles approach, sharding we need to use when one machine is not enough. That db6.r16 machine is not enough, and you're running into limits. That's when you must do it. But the second level sharding, or the second side to it, is the DDD style partitioning. I'm intentionally sidestepping on sharding and going to partitioning. Minor difference there. And if you can preemptively do that, then I like to do that as well. I keep coming back to universal scalability law, in this context, right? What is your contention and what is your coherence? How much chatter do you need between the different shards? Do you need any chatter or coherence between the two shards at all, or is it just a smooth partition? And then in DDD style, you're going to need some coherence. And I I sort of approach these decisions from those angles. Like I said, I really do prefer application level logical sharding over automatic, like historically preferred.
Sorry, I think I might have misunderstood the question also.
Or maybe I did.
No, I think
both were a part of the question.
Yeah.
Partitioning and sharding.
Yeah.
Both answered one of each part. So.
Yeah. Cool. Yeah. Srihari, do you have anything to add to that?
Mostly no. I think the other part of the question, and I'm looking at it, it says what data points to collect before sharding and after sharding to measure effectiveness. I think do it, like do your query or whatever that you wanted to do before and after sharding. That's your measure. What you are ultimately like, what's the ultimate test? Your application should run fast, or your data access or entry should be fast in a certain way. Localizing your data into one particular place, right? Whether it's a partition or a shard is what you're ultimately achieving. Read less, get exactly the information that you want. So if that's hard to do from one big table, you're putting it up into multiple parts in either a partition or a shard in a different machine or whatever, right? So you're optimizing for resources. Think about it like that. You want, like, instead of, okay, for example, geosharding is a very simple, make sense kind of concept, right? If I have all my customers in India and all my customers in Singapore or something, and their data will never intersect, and I want each of them to be fast, it's a fairly straightforward idea, maybe to put them in different places if it's not performant enough.
Yeah, cool. Thanks a lot. So I think I'll close it with one small question. Okay. So what is your advice for someone starting now? Should they worry about all these, and what should they keep in mind?
Oh my God, I feel like preaching so much. Come, shameless plug. Come to my. I'm conducting a schema design workshop. Come to the workshop. Honestly, but yeah, I think first principles thinking again. There's a lot of chatter about first principles these days, right? But with databases, really, this is where first principles thinking really shines. That you want to be true to your domain. You want to represent your data as truthfully as possible. Be like, have it reliable, like show reliability, high integrity, etc. And I like to come and approach it from that angle. Is that the question? Am I answering the right question? Like,
yeah.
Okay.
I'm saying my question is basically what to kind of keep in mind when you're starting fresh, right? I mean, so you were saying data integrity is the first thing to kind of keep in mind. Yeah.
Okay. Domain modeling and data integrity. I think those are two that are my favorite.
Cool. Anything, Nid, you want to take on that?
Right. Yeah. Starting out and scaling up are two completely different problem statements. So starting out is much simpler. Like starting out is follow the conventions put forth by so many people who have done this before. Like if you're starting out, you don't need to go forge your own path. Like you follow the conventions that have been put forth by so many else. Like and then when you hit a particular unique sort of problems that only few people have found, then you go and forge your own path. So yeah, I and just to add to what one of the reasons that we sort of have been harping on Postgres a little bit is because of the community. The Postgres community is the most active one I have seen in any of the open source libraries and open source software that I've used. And there are people on, like, I have asked questions on Postgres IRC and gotten response within seconds and gotten amazing response, like exactly what I wanted to hear, exactly the explanation I wanted to hear. And these people who hang around on IRC are experts in what they're doing. So yeah, there are community to help you out when you're starting out.
Cool. Yeah, Srihari, you want to say something about that?
Sure. I think I'm a little bit with Swanand on this, where like I'm not sure what I'm supposed to answer. Give advice if that's the question. I would say try to write down your problem statement very clearly to the extent that you can. Like if you're starting out, write down what you want from your database. Right? Like write down exactly what you will ask your database. What are the questions you're going to ask your database? So that's queries, right? And then write down what all information you're going to write into your database. Both these things together will inform you schema design, right? Like in terms of taking a first principles approach, right? I'm just kind of trying to break it down. What does that involve? Write down a problem statement, break it down like this. Just write what you're going to ask it, write what you're going to put in, right? And then based on how quick you want an answer for something or how correct you want an answer to be, you can look at different options. If you're starting out and you know very little about database, just pick Postgres. It's a very, very safe default. And it will like accommodate the various different kinds of features as well. But otherwise, I mean, the database world is extremely large and wide. It's a huge industry, right? So you have key value stores, graph databases, columnar stores, temporal stores, embedded databases, distributed databases, right? So it's a big world out there. So you'll have to do your research to figure out what database you'll want to use. Get your schema design right, get your domain design right. Everything else can be kind of dealt with a little later.
Thanks a lot. I think with that, I would like to kind of close the session. Thanks, Nid, Srihari, and Swanand for sharing your wisdom. It was an amazing discussion. Thanks everyone for joining. I hope you all enjoyed it as much as I did. See you for the next episode of the Scaling from First Principles. Thanks everyone.
You're welcome. I hope we contributed something more than use Postgres.
Yeah, I hope the same. And thanks, Anand, for this was a nice discussion. I enjoyed it.